If you're playing about with single board computers or PCs, you're going to need to know how to handle bootable devices. So in this video, I'll show you how to create them, manage them, and then how to recover your SD card at the end so that you can use it again. Hi and welcome to Bytes and Bits. Quite often when we're going through our project work, we end up having to create a bootable USB drive, either with a sort of a thumb drive or an SD card or something. And that's when we're sort of installing operating systems onto things like Raspberry Pis or onto our PCs. So I thought I'd take this video to really just sort of cover that whole topic, and hopefully this will be especially useful for people who are new coming into doing this type of work. So I'm going to have a look at what the USB bootable drives actually are, how we actually create them, how we can then manage them and prepare them for use within our devices, and then how we can fix them when things go wrong, or after we've used one. Quite often they end up not being readable inside our Windows machine, so how can we recover them so we can then get back and reuse them for some other projects. So let's start by having a look at what these things actually are, and we'll get right into it. So all computers need software to run. So no matter what type of computer or microprocessor you talk about, this holds true. Now this software can be held in several different types of storage, such as physical ROM chips, a hard drive, or as we're working with today, a USB memory stick or SD card. Now please do note that I'll probably swap between talking about USB memory sticks and thumb drives and SD cards throughout this video, but we're going to treat them all as the same sort of thing. Now, when a microprocessor is first powered on, it expects to find a memory device attached to it that will contain some basic software to allow it to communicate with the rest of its hardware. Now, this is usually called the BIOS, or Basic Input-Output System. So once this BIOS has loaded, the processor is then able to communicate with other storage devices, such as your hard drives or memory sticks. Now the BIOS software will scan these devices to find one that is formatted in a specific way so that it is recognised as a bootable device. Now if the BIOS can't find a storage device that's formatted in this special way, the system just simply won't start. Now the format of these bootable devices isn't usually something that you can easily create yourself. So we need to use ready-made snapshots or images of correctly formatted drives, which we can then burn onto our blank storage device to turn those into bootable media. So once we've done that, we can then use it during the boot sequence of our system, and the BIOS will be able to load our software and start the computer. And at this point, the code embedded into our boot media will start to run. So now that we understand the boot sequence, we need to consider how our device starts up. So if you're setting up something like a Raspberry Pi, there's usually only one mass storage device connected to the system, which will be your SD card. Now as the Raspberry Pi boots up, it will find your card and start to run the software on it. If we're working, however, with something like a PC, there'll usually be a number of possible boot devices connected to the computer. So you might have a hard drive, a DVD drive, as well as the USB stick that you really want to boot from. So how do we make sure that we boot from the USB drive and not something else? Now, as we talked about earlier, it's the BIOS software that finds and loads the boot code. So if there is more than one boot device, it needs to be told which one to use. On most computers, we can access a BIOS settings screen by pressing a specific button on the keyboard as the computer powers on. Now once we're into this BIOS settings screen, there's usually a section which lists the boot order during computer startup, and this tells the BIOS which devices to check first to see if there's some bootable media available. Now alternatively, most PCs also have a boot menu that you can access by holding down a specific key in your keyboard. Now for all these keys for different systems, please do check the documentation, for they do differ for each machine. And this, of course, then this will bring up a boot menu, and you can then just simply select the device that you want to boot from. So once you've done that, the computer will check to see if your USB drive is plugged in, and if it is, it will try to boot from it. If it's not plugged in, or if it's not formatted as a bootable system, then the computer will try the next item in the boot order list. So that's the boot sequence and why we need to have a specially formatted boot device. So let's see how we actually create it then. So the first step in creating a bootable USB drive is to get a drive image. Now mostly this will be a simple download from the website of the software that you're trying to install. Now in this tutorial I'm going to use a Linux boot drive so that we can see the general process. However, pretty much all boot drives are created in the same way. So once you've downloaded your drive image, you need to burn that onto your SD card. So for this we're going to need a few bits of hardware. Now if we're using a USB memory stick, we can usually plug this straight into our computer. If you're using some sort of memory card, then you'll need a card reader device that has a slot for the type of card that you want to use. Now I tend to use a USB adapter that allows me to use the full range of memory cards available, and this simply plugs into a USB port on my computer and I'm then ready to go. Now you'll also need to consider the size of your memory device. So if the bootable media that you're creating is simply to install an operating system, then it just needs to be big enough to hold the installation files. If, however, you're creating a bootable drive for something like a Raspberry Pi, then you're going to need something a little bit bigger, as this bootable drive will actually become the hard drive of your Raspberry Pi system. So if you don't leave enough spare space for your applications and data, you're going to need to rebuild the whole thing at some point. Now that we've got all the pieces in place, we need some software that will take our drive image file and transfer it onto our memory stick. Now this is not a simple file copy operation. If you try doing that, it just simply won't work. This image contains information about the format of the final drive. So we do need to use one of a range of programs that will actually do this for us. So if you're creating a drive for a Raspberry Pi, I advise that you use the Raspberry Pi Imager. So this will help you select and download the correct image for your Raspberry Pi if you haven't done so already, and then it will burn it onto your USB drive so you can simply plug it in and off you go. Now in this video I'm going to be using a package called Etcher. And this makes the whole process very, very simple. And you can also use this for pretty much any bootable drive that you want to make, including Raspberry Pis or Windows or so on. Now, if you are looking for something with a bit more advanced features, then try Rufus. Now, this allows you to create and modify the bootable drives for a wide range of applications. So something like if you've watched my Windows 11 installation video, you'll see that I use it to modify the Windows software to allow it to bypass the hardware checks for older hardware. So whichever package you decide to use, simply download it and install it onto your computer. So when you run your burning application, you basically have to go through a three-step process. So we first need to select the file, and that's the image file that you downloaded. So I have my Ubuntu image file sitting here. You then need to specify which USB device you want to put it onto. Now, usually your software will hide any of your hard drives, but do make sure that you select the right device here. Remember, everything we do here will completely wipe that device. If for some reason one of your hard drives turns up and you select that, obviously that will put you into a real world of pain because that will be gone. So I'm going to select my USB device here. And then you simply hit the flash button. And at this point, our software is going to start transferring that drive image across to our SD card or our USB stick, and that will then create what we need. So this process can take quite a long time, depending on how big this disk drive is. So let's just let that run through, and then we'll see how it gets on. So once the flashing process has completed, you usually go through a verification stage where really it's going to check to make sure that the image has been burned correctly. Now usually this will of course go through fine, but sometimes you will get verification errors. So if that happens, the best option is to try and just burn it for a second time just to see if that clears the problem. But if the error persists, you can try a couple of different routes. So I'd always advise trying your newly created boot device just to see if it does actually work. Sometimes the verification process can have trouble reading some specially formatted cards, so even if it fails, the device might still be correct. However, if you get errors during the boot sequence, it probably means then that your SD card has become corrupted. So you're going to have to use a different device. So SD cards and memory devices can just simply die. They have errors in the actual hardware inside them. But we'll have a look at how we can test them a little bit later in the video. So eventually your bootable USB device will be ready, and at this point you simply need to put it into your computer and then turn it on. And if everything's gone correctly, your BIOS will correctly recognize your boot media, boot from it, and start installing your software. So you should now have your project up and ready and running. So once you've gone through the whole process of installing your software and getting everything up and running, you should all be ready to go. But sometimes there are a few maintenance tasks you need to take care of just to make your SD card or your memory stick just run that little bit better. Now, if you're using a Raspberry Pi or any of the other sort of single board computer operating systems, they will generally sort themselves out on your first boot up. But some images are created for smaller memory devices. So if you think about it, when people create these disk images, they want to make sure that it works on as many SD cards as possible. So they really create the image for as small an SD card as they need. And the problem you have with that then is once you burn that onto your SD card, if you've got a bigger SD card, some of the space just doesn't get used. So I've got a Linux distribution in my computer at the moment, and I have a data drive here, data drive M. So if I look at the properties of that, you can see here that I have an 8 gigabyte space allocated to this USB drive. Now the actual device itself, the SD card, is a 64 gigabyte drive, so there's a big portion of that is just not being used and is being wasted at the moment. So I need to try and get that area on my drive expanded out to fill the whole device. Now the best way to do this is to use a partition manager. And that's what I've got just loaded up here. Now, depending on what system you're using, you'll need to find a partition manager that works on your system. If you're on Linux, I would suggest looking at something called GParted. I'm on Windows here, so I'm using a package called Partition Wizard, and I'm using the free version of that because that actually has enough facilities to do everything we want. So if I have a look at the actual disk drive that I have in my machine, and that's disk number 5 down here, we can see that the image has actually been put onto that SD card, and it has divided up the SD card into a number of sections. So you can see here we've got one section here which is 2.75 gigabytes image size, another block here, and so on. And there's my data portion, which is 8.2 gigabytes. And then I have an unallocated section over here of 47 gigabytes. So at the moment that is not being used. And these sections are what are known as partitions. So when we create a disk and we sort of format it, we do have the ability to divide it up into different sections, and each of these sections in effect acts like its own separate little disk drive that we have in our computer. So if this was my Linux boot drive, I would have here my data section, but I want to make that as big as possible on my SD card. So I can do that by simply just, again in this package, I just simply right click on that, and I here say that I want to resize that partition. And you can see it's giving me an option here, and all I simply do in this package is to drag that out. to fill up the whole space and click OK. And you can see that that now is filling that rest of that drive space. Now again, depending on what software package you're using, you'll do this in different ways. You can do this through the terminal or the command line. It obviously is a little bit more complicated. So if you are starting out on this, I would advise you try and find one of these graphical packages which lets you do it in a much more easy way. So in this particular package, although I have resized it there, it hasn't actually done anything to the disk drive yet. It's waiting for me to say, yes, I'm happy that everything is okay. So if I simply click on apply, I will find then that that will apply that. It does sort of give me a little warning up here saying it's going to do certain things to that memory drive. So if I say yes to that, it will run through. It will update that partition information. So if I go back down to my Windows Explorer and I actually now look at the properties of that drive, we should now find that that drive is now filling all of the spare space on that SD card. So it's gone from 8 GB up to 55 GB to fill that up. So the last thing I want to cover in this video is how we recover our SD card or memory drive after we finish using it. So on some of the drive images that we create, and again, I've still got this Ubuntu installation disk in my computer. You can see here, again, these are the various partitions that we saw in that previous little example. But Windows has a problem with Linux disk drives in that it doesn't actually recognize the format of them. And you can see here that it's having trouble sort of working out what to do here. Now, quite often, all you simply have to do is to re-image or re-burn an image over the top of this, and everything will get cleared out by your drive burning software. But sometimes that actually doesn't work. For whatever reason, the particular format of these partitions, Windows itself can't get rid of them. So that's what we're going to look at next, is how we can actually clean out that drive and get it back and being able to use it again. And again, the best way to do this is to go into your partition software. So we can see here these partition software packages tend to work at a much lower level than Windows. So Windows has to work through the general operating system, and whenever you try to format and delete disks, it has that layer which doesn't understand this deep low-level data structure on your USB drive. These partition bits of software do understand that and can obviously work with that. So we can see here that this software has identified there's actually 4 partitions here. So there's the K, L, and M drive that Windows was able to see. But this 4th partition here, Windows couldn't even see that. But what we need to do is we basically need to wipe this disk. And again, in this particular piece of software here, I can simply right-click on that disk drive, and I can say here that I want to delete all of the partitions on that. So if I delete all the partitions, again, it's saying me, am I sure? Because if I do that, of course, I'm going to lose any data that was on that disk. But again, I am. So you can now see that it has taken off all the partitions. So I have an unused 58 gig free space 58 free gigabytes of space on my hard drive. So if I apply that and say yes, you should see now that it has removed those partitions, and I now have a totally free USB drive. If I come back into my File Explorer and I come down here, you'll see that it's not actually listed in my list of drives. And that's because although we have taken off all the partitions, we've now left it as a totally blank disk drive, which we can't use yet, and Windows isn't even recognizing that it exists. So what we need to do is, once we have cleared all the partitions off, we need to put one partition back in there. So again, I'm going to create a partition. You can see that automatically it says I'm going to make a partition that fills the entire space. So I'm just going to call this partition my data partition. Again, I can specify here how I create that. So the main important one here is I'm going to create it as a primary partition. It will automatically just select the last drive letter on there. The file system I'm going to use then, that is important for me. So you can see there are a lot of different types of file systems on here. So a few of these are Linux versions. So these ext 2, 3 and 4, they are Linux versions. The ones at the top here are ones that Windows can understand, and Linux can actually understand them as well. Quite often when you buy a new SD card, it will be formatted as an FAT32 card. NTFS is the sort of preferred Windows version. So any of these ones up here will allow you to use this SD card as just a general purpose data card. So I'm going to format mine as an FAT32 card. It's filling up the entire space. I can say OK for that. You can see that that partition is now logged in my drive. I can then apply that and say yes. My partition software will now create that partition and it will format it as an FAT32 partition. So now if I come back into my Windows Explorer, you can see I now have my drive K, and if I have a look at that, you can see there's nothing on it. If I go to its properties, you can see we now have a USB drive. It's formatted as an FAT32 drive, and it now has the full, well again, it's a 64 gigabyte drive, but I have 58 gigabytes of free space on there. So that's got my card back, being able to use it now just as a general purpose disk drive in my computer. So hopefully that will allow you to recover any disks and memory cards that you are using for your projects. But there will be some situations where you will try to go through this process where you will delete the partitions and they won't delete from the drive. Now at that point, it begins to look like the actual SD card has become corrupted. You can check for that in most bits of software by doing what's known as a surface test. So if I right click on my disk down here, I can do a surface test. And what that does is it starts to check every single piece of data storage on that drive to see if it actually works or not. So really what you do here is you will simply say, you will start that off and it will start to go through looking at all of your hard drive space. So that process, as I say, will sometimes come back saying that there are errors on the disk drive. At that point, really, if you've got a USB drive or a SD card, really that is now dead, and you will need to get rid of that. If it comes back with no errors and you still can't delete the partitions, I'm not entirely sure what that does mean. I tend to, if that happens, just get rid of the disk drive anyway, because I'm just going to end up spending hours and hours trying to work out what to do with it. So I hope that just gives you a little bit of a help. So if you do get in that situation, it's not very common. I think I've had it once in the past sort of 4 or 5 years, but there is the possibility that you will have a properly corrupted and destroyed SD card, and that's really how you would identify that. So that's my take on using these sort of USB drives and SD cards for various bits of your project work. I hope that's given you enough information to, if you're not familiar with it, to get started, get them produced and use them. And then, as I say, after that, to hopefully then be able to recover those drives so you can reuse them in other projects. Now, if you've enjoyed this video, please do make sure that you like and subscribe to the channel. I do a lot more videos on sort of project work, gaming, and so on. I look forward to seeing you hopefully in another video very soon. And bye for now. For more games programming, electronics projects, and retro gaming, please make sure you like this video, subscribe to my YouTube channel, and visit my website.